Right, okay, so my name's Rob Dickson. I'm a project director for Mott MacDonald. My background is very much as a design manager stroke project manager coming to this. And about halfway through my presentation, I'll turn over to Ian, who originally, his background is actually hydraulic and tunnelling engineering. He's actually one of our senior BIM coordinators now. So just very quickly, we'll talk about why digital, but I think we all know the answer to that. We'll touch on Victoria Station upgrade, following on from Charles's presentation. We'll take you through the work we're doing on the Northern Line extension at the moment, and then the future. I'm not going to read this slide out because we already know all this. So basically, the cost of data storage is coming down massively. The power of computing is increasing exponentially. To me, there's a danger, as a layman on this, there is a danger of data proliferation if we don't know what we're actually going to do with the data. So I'll come back to an example. So David talked about Heathrow. There's one tunnel at Heathrow, and I believe that is the Airside Road tunnel, possibly, just before T5. My first job at Mott MacDonald was to hold a tape measure across the Airside Road tunnel where we implemented something called the Observational Method. So for those of you that don't know, the observational method is where you've got a very, very deep cut and cover excavation. We generally not, as engineers in the soil, we can't be 100% confident of soil strength, so we're always a little bit conservative. So to prop these deep excavations, we have enormous props, and as geotechnical engineers, we're looking at this thinking, we probably don't actually need them, but it's too risky to leave them out. So in the early 1900s, an American professor called Ralph Peck came up with something called the observational method. This originally wasn't part of the presentation, but it's coming to this. And we leave these props out and monitor these excavations as we're going down. And we have the props on the side ready to put them in as a contingency. Now, this was a fantastic job. And Ralph Peck always used to say, if you can measure it with a ruler, please use a ruler. And we probably did that whole job with about 10 readings a day for monitoring data. And these days we're collecting tons and tons and tons of data. And I think sometimes there's a danger of, are we getting the good data, the wood from the trees? So what we're going to talk about, we'll talk a little bit about why Mott MacDonald started working in BIM down here, take us into asset information management, because the key thing to make this data useful is going into here, and then leading into smart infrastructure later. So where we started, in a little bit more detail than Charles, on VSU. So we're back in 2006 now. Now, I've got to be honest, we did actually do a little bit of one-way collaboration with Charles before we started. So we got hold of Charles's slides earlier in the week. And Ian and I had a look at these and we thought, blimey, he's got a lot of slides that look very similar to ours. We'll take out a lot of the VSU ones, but we'll leave in the case study of the jet grouting, because Charles is clearly very senior. He's either not going to want to talk about the detail or he won't actually understand it or know it. Now, we should, no, what I can say is, as a trusted client, our ultimate client of ours, we should have known that London Underground were a better client than that, because that is absolutely the case. Nonetheless, there's still a couple of lessons which I just could, so everything Charles has said was perfect, but there's just a couple of little things I think I'd like to add to that. So, actually, going back one slide, first of all, let's just go back one. Just randomly, the month before last, that rather ugly image there appeared in the centrepiece of the new Civil Engineer, and it was all about the Bim Revolution and digital revolution, how it's working. So this thing you see here is looking underneath the new North Tick Hill that Charles talked about that just opened. So back in 2006, really, I suppose it was 3D CAD Plus, but we called it BIM because you would do. But so we had some data in the model, and there was an aspiration that some of that data was going to be used for asset management. But the main reason we went for BIM was because this project was so spatially complex. You only see a few of the services here, but we're threading piles around utilities, etc., etc. But another little lesson to me was when this article appeared in the New Civil Engineer last month, there was only one image of BIM, and it was this one, appeared in random. It's actually upside down, right? And I don't think anyone out of the whole industry, apart from me who'd worked on the project, actually spotted this. And it tells me that just because something looks a bit cool, it might actually be rubbish. And we mustn't think it's good. So we used, originally, we developed with Keller the jet grouted. They only wanted to work in 2D. We thought, you've got to put all these jet grout columns that Charles described earlier, and we need to thread them through hundreds and hundreds of utilities. So the first thing we did was we tested the worksite fits, etc., etc. We had all the volumes in the model so that we could extract it. So Keller's, when they did grout up the basement of the Victoria Palace Theatre, they knew that something was happening because the grout, or they should have done, because the grout volumes were larger than they should have been. When we'd done that exercise, we thought, that's great, that's done. Right, but when we actually came, because Keller's had filled in all the voids at the surface and they knew where the columns were, we didn't actually realise, although it was blindingly obvious, I think that will play if we come down here. Start that in. But we did, anyway, we didn't, what this shows is a model through the tunnel with the water levels and the voids coming as we go through. But that model was used 2 years later every day down at tunnel face, as Charles said. Now, I don't think anyone on the project realised when we first did this modelling that 2 years later that was going to be useful. It dawned on us about a year afterwards that as a safety tool this was absolutely fantastic. That came through. So I think there's another lesson there. When you're collecting data, you're not always sure how useful it's going to be down the line. And there we see, so this one, there was a void in the model there, and we found it, as Charles said earlier, straight away, and it worked beautifully. So on that note, I'm going to hand over to Ian, who'll take us forward into the asset information management piece, and looking forward into the future. Thanks.
Good afternoon, everyone. My name is Ian, and as Rob said there, I'm responsible for the BIM delivery on the project. And one of the key roles in that is essentially meshing our engineering with the technology we have available. But first, I'll just give you a bit of context about the project, so what follows makes sense. So in a nutshell, the project is 2 new major stations and 2 new permanent intervention and ventilation shafts, as well as all of the tunnels, rail systems and building services that connect it all together. The project was commissioned by London Underground and being delivered by Ferrovial Langeroog, Flo, and we're acting as lead designer on their behalf. And really embracing technology and using what's available in terms of digital information has been born out of necessity as much as anything else. You can imagine putting something like this in London isn't easy. There's all sorts of internal interfaces within our design team, but also with existing planned assets and various other interfaces that we need to deal with. So really embracing digital information has been the only way to deliver this effectively. So I'm going to touch on how we've used BIM on the project from a design perspective and move on to some of the benefits we've had from the construction area, onto asset management, and then just close off with some final thoughts on smart infrastructure. So the first part of this is being delivered by organisations and companies worldwide, and collaboration, as we've heard today, is a really key part of that. So the way we've handled this is through using something referred to as a common data environment, and a lot of you will be probably familiar with the term. What that is essentially a system that allows us to produce, manage and share information effectively across the project. So making sure that the right people can access the right information and use that effectively. Mott MacDonald hosts the common data environment in this case, and we use something called ProjectWise, and that's a system that has electronic controls in based on access rights. So certain people can do certain things to pieces of information at different stages in workflows. So it means that whoever you are and where you're working, your approach to delivery is the same across the board. We use it as the designer, but also Ferrovial Langeroog and that extended supply chain work in our common data environment, so they can reference our design information once it's at a suitable level. And also importantly, London Underground have access to this information. So how does that feed into our assurance and design development? So this represents a typical asset that we would design and produce. This is 9 Station. Each discipline owns, what you see along the bottom there, a composite model which contains all of their relevant design information. That model is broken down something like this, so it typically be split by floor or by system. And once certain parts of that information have been approved, so they go through this PS 1192 workflow. Again, a lot of you have probably heard about that standard. So once we get to this stage in the workflow, the other different disciplines can then access each other's information and reference it together so they can coordinate effectively. So that creating of a federated model is fairly standard practice, and where we've really excelled on this is in the use of technology to help us mark up and capture the team's comments. So we have a cross-discipline review session every week for each of the packages, and that will often involve Ferrovial Langeroog as well as London Underground. so we can capture their perspectives on constructability items as well as the operation and maintenance side of it. So if I just show you a video of that in action, this is a model of one of our stations. Down the left hand side I've got different versions of the same model available, so we can switch to different points in time and see how the design's progressed. Along the bottom here I've got the various different markups which capture what the issue is, who it was assigned to, what its due date is, and what the current status of that is. So if I look at an example, at that point in time I can see that this DC cable route looked too small. I can then reapply this view to my current design and see that actually that has been closed out. So I can very rapidly understand which issues are ongoing and which issues have been closed out in my latest design. And we've got 200 odd actions in there, so you can imagine looking after this in an analog way is quite difficult. And so this allows us to rapidly close out actions. Another example from an operational perspective, this HVAC ducting, whilst it worked technically, wasn't very good from a maintenance point of view, so it was flagged up. And actually, if I look at that in my current design, I can see that that's been rerouted, so it still works, but actually from a maintenance point of view, it's much better. So this is about really involving all the people that are going to use that asset and getting the best value out through sort of developing the design more organically with all the right inputs and being able to audit and track that. So the other aspect is the construction side of it. Flow have been responsible for a lot of the good innovations that have been done here, but I'll just touch upon one or two of them that I think are worthwhile mentioning. So everybody's seen point clouds. That's a point cloud of the Kennington cross passages. So that's got its obvious value, but where it becomes really interesting is when you start combining that with other information. So what we have on the right hand side here, this is the Battersea station crossover box, and at the end of each week the contractor does a laser survey of the site. So we overlaid that laser survey on our design model, and then we can create this thematic map and identify any out of tolerance items. So we can see there, pretty much on a weekly basis, we can identify any issues that we need to either A, see if we can revisit from a design perspective to accommodate, or B, whether they need to go out first thing next week and rectify those issues. So I think the implications are huge in terms of program and cost mitigation, and we've got a lot of benefit out of doing that. It's a relatively simple technique, but just making the best use of the technology that's out there. The other really valuable thing regards health and safety, we maintain something that's referred to as a virtual construction model. So that's essentially the contractor taking our design model, stripping out what's not needed, and including all of their temporary works and logistics. So that's what you see on the left, albeit a bit tarted up. It looks a bit dirty in real life. So this is updated on a weekly basis, and all of the contractor can access this information. So before coming to the site, they've got a real level of familiarity with what it is that's going on in the yard. They use these in CDM reviews so that the end client can get that confidence that we have understood and actually closed out a lot of these health and safety issues. And also to the layperson, it communicates the status in terms of program, rather than having to look at a horrific P6 breakdown. Moving to the asset management side. So the first part of understanding this is grasping what we refer to as a level of detail or development or definition, depending on which book you pick up. So the first point is what do we mean by how much graphical detail will be in there. So that's typically how our design would transition between REBA 3 and 4, the MEP services. But what's more tricky to understand is what do you need from a maintenance perspective to understand how that asset is going to work. So the way we've approached this is by having a benchmark model. So each different discipline has outlined all of the assets that they're going to use across the project. So for public health here, you see I've got all the different valves that I'm going to use. So everyone can clearly see what that's going to look like, both graphically, but also, and possibly more importantly, what sort of data will associate to that object. So there's an example of some valves there. We've also got firefighting, structures, premises, all the different disciplines. And it's important also to recognise that it's not practical to shoehorn every last bit of data into a model. In fact, sometimes it's better referring out to equipment schedule or specification. So that's what we see in the bottom here. This information is held elsewhere, but it's linked in the top information. So just in terms of the non-graphic data, this is the client's asset registration form. Down the left-hand side, they've identified everything that they deem the various different asset classes. And then along the top there, we've got all the different attributes that would be required in terms of maintaining that asset from a long-term point of view. So the yellow items are things we've picked up and said there that we can provide that. So for a wall, we've got material, finish, color, various bits of geometry. Is it glazed? Does it have a void in it? That sort of information. So what I can do then is map that back to my benchmark model. So if I take all my walls, look down there, I've got my various different attributes mapped so that when I do place a wall, I'll be prompted to enter that information because I know it's needed downstream. Looking at one of the shaft models, again, if I go and inspect this wall, you see down the right-hand side here, all of those pieces of information are included in there. So that can be done on an individual basis, or we can schedule the whole lot out in bulk so the operator can use that information. And again, the intricate detail wouldn't force everything back into here, but we allude out to that in the form of this specification document, and then go to that item within there, and we've got all the additional information that might be needed. Yeah, so that's a bit on the asset maintenance side of it. So all of that information for each discipline can now be exported in a really structured way, and sense can be made of that structured data. Just some other things that we've been looking at in terms of trying to get more value out of this data that we've created. So we've looked at utilizing gaming engines. So we took our design models and dropped them into a gaming environment and been able to create immersive experiences. And so this real-time visualization has got a lot of value in that you can address queries as and when they arise. So again, this is one of the shaft models. So if I go to the HV room, I'm just walking around with an Xbox controller here. But you get a much more better perception on what the finished product or asset would be. And the use cases for something like this are quite compelling. So you could walk the fire brigade through this and show them their evacuation and maintenance route. You could engage stakeholders in terms of local residents and show them what the view would look like from their point of view above ground. And it's really much more interactive than using typical stills. And the point here is really just all about reusing that digital information that we've already produced. So as long as we produce high quality, good information, we can get a whole range of benefits and value from that. The other side of this digital thing is augmented reality. So what you see here is I've got a drawing of one of my shafts. On the right hand side I've got equivalent to like a QR code. I've loaded in that shaft model so that the camera on the tablet will find that code and overlay, too short, it will overlay the model on that drawing. So you're presented with all of that design information. You can toggle between the various different disciplines that we saw in the earlier slide so that only the right information is presented to you. And again, this is hugely valuable. So if a picture paints 1,000 words, then that's worth whatever it is, but a lot more than, yeah, let's say 10,000. Yeah, but the amount of drawings needed to convey that level of information would be substantial. Whereas we could give everyone a 200 quid tablet and say, here's a much smaller volume of drawings, but all the information's here and accessible. And that's probably extensive. Oh yeah. Just so we know that this isn't all theoretical or academic, the project is on site. We're about 2.5 years in. Yeah, so a lot of the things that were mentioned there are being put into practice and the project is moving ahead. So I think that wraps us up on the Northern Line extension. Just some closing thoughts on smart infrastructure. So Rob showed that graph early on about BIM and then moving up towards asset management. And then finally, obviously, the last goal on this is smart infrastructure. And you've seen this diagram already today. So that's good collaboration going on. It was deliberate. So as designers, where I think our real input comes into this is in the bottom tier of this, in that we provide structured information to the client that can be used as a baseline so that when you come into this bottom area and you're capturing all these pieces of information or data from the assets, you've got something to measure and baseline against. and that really can be good in terms of giving you indication on performance. If you know what it is it's checking against and what the actual readings are, you've got that information that you can use to inform your decisions. The next 2 points on the pyramid I think are more with the client and operator and owner. But once all that sensible information has been gathered and it's got a good structure to it, we can use machines to identify trends that'll help us make decisions. And then finally, you've got doomsday when none of us are required and assets are managing themselves. I don't know how far we are away from that, but I've seen some pretty impressive things where computers start beating people at games that they've been playing for 60 seconds. So I wouldn't think that's too far off. I think that's probably, yeah, time-wise done.
Do you still need me as a person?
Yeah, you're good. No, you're good.
Sure.
Yeah.
Excellent.
You can stay.
Thank you. Well done, guys. Thanks.